Hello and welcome guys, my name is Steve and welcome to my channel where I share my engineering experience with you. So if you are new to this channel, make sure to subscribe if you aren't already. So in this video, we're going to continue with the Reminders CLI video series right where we left off last time. So if you don't know what Reminders CLI video series is and you want to be up to date, you want to be on the same page with us, make sure to check out the first 3 videos where we started to build the application from scratch. However, if you don't want to waste your time watching all these videos in order to write the code to be on the same page with us, make sure to download the source code or download the zip archives. So it's very easy to do so. Just go to github.com/gophertooth/reminderscli, and I made sure to link all of these archives in the repository. So as you can see, you have the YouTube video links and you also have the source code, the zip archives, which you can download, and you can just start writing code from the exact point in time where we stopped last time. So with that out of the way, let's dive into this video. So last time we played with the command line basics, which are the bases that we're gonna use in this video. We're gonna use pretty much most of the concepts we were playing with last time in the last video. However, we're gonna have to adjust our code a little bit. So just to remind you what the application that we are building looks like, just take a look at this diagram. As I was saying, we have the command line, or the thing which we try to input things or commands, which is also called the terminal. Then we have the command switch, which is the thing we're trying to build in this specific video, and which is the thing which we tried to play with in the last video. The HTTP client is the thing which stays between our command switch, which we are trying to build, and the backend API, which we will be building later on. So we're gonna pass in requests from the command line application through the switch. It's gonna go through the HTTP client, and then that request goes to the backend API, which is gonna process it, do something about it, and then return us a response. And we're gonna process that response in the HTTP client itself, and then give a response which is readable and usable for the command line client. So the commands we're talking about is create, edit, fetch, delete, and help, of course. Let's dive into each and every one of these commands and see how exactly they are gonna look. So let's talk about the first command, which is the create command. So this command is going to receive 3 flags or 3 arguments, and you already know what flags are, or arguments. So we're talking about title, message, and duration. So title and message will be strings, and duration, of course, is going to be a time.duration. Then we have the edit command, which basically edits a reminder which we created earlier. So it receives the exact same flags, the exact same arguments, except it also accepts an ID. So we have to know like what we're editing, what kind of reminder we are editing. That's why we accept an extra argument, which is ID. Notice here we can only edit 1 reminder, not multiple reminders. Then we have the fetch command, which you're right, is gonna fetch a list of reminders by ID. So we provide an ID, and if you want to fetch multiple reminders, you just provide multiple IDs in the command line. The ID flag, or the ID argument, which we will be parsing later on, it's a flag.value, which means it's going to implement the flag.value interface. And lastly, we have the delete command, which you're right, it deletes a bunch of reminders. So it again accepts the same ID flag or the same ID argument, which is a flag.value. And of course, we're gonna have one last command, which is the help command, which given a host, it's going to check if that host, in our case, the backend API, is healthy or not. Let's have a look at some of the previous examples and see what exactly is happening there and how can we use this example for our current example. I will consider you follow the first 3 videos, and you should have a structure which looks like this. Let's say you open up examples, and inside examples, you have something like command line basics. So inside command line basics, last time we did a couple of examples. However, what I want you to focus on right now is open up flag set. So let's open up flag set main.go. So looking at this example, you may think this is a well-organized example which we could use for our example. However, this example specifically has some problems which I think needs to be addressed. So let's do a quick exercise of imagination. So imagine in this example, instead of 3 commands, you would have to parse something like 100+ commands. The switch would be huge, and it's not flexible at all. It's very tightly coupled to the switch, and you're always gonna change this. So if we go back to the open-closed principle, it says it should be open for extensions and closed for modifications. Let's also imagine like most commands don't change very often. However, there are 3 to 4 commands which change pretty frequently. What exactly this means? It means you will have to change the switch all the time, when in fact just 3 or 4 commands are the ones that need to change. And if we talk about commands, usually you don't want to repeat yourself even when creating commands. So sometimes you may have a command which uses another command or even multiple commands. So how do you do that? You'll have to copy paste logic, or you'd have to separate that logic in different functions and then call those functions like that and that giant switch. And this is going to be a mess. Let's also imagine you want to split this giant switch into multiple files. How would you do that? It looks ugly, it looks unmaintainable, and you have to scroll a lot for the same switch because it's all in one place. It's huge, it's very hard to follow and very hard to read. That's why we're trying to separate things into very small units, functions. So one thing we're going to do in this example is we're going to try to map commands to functions or try to use a more functional approach. So we're going to have the command as a string and we're going to map it to a function. So whenever we have to modify a specific command, we will only have to modify a specific function, and that function may even live in its own file. So it's, as you can see, very manageable, very easy to use, easy to maintain and modify in the future. And then to make this approach work, of course, we're going to have a command switch which loops over this map of functions to specific commands and simply make sure it checks only against those commands which we have declared inside that map. That's why we're going to use a functional approach as opposed to this giant switch, which in my opinion is not a very good approach, especially when you're trying to build, I don't know, big applications, big CLI applications. All right, so now that I showed you the problem and how exactly we can fix it with this giant switch, let's go ahead and dive into writing some code because we need to write some code in order to fill in this command switch. I will open up client, and inside client from the first video we have http.go and switch.go. We will be using both of these files, but for now we're gonna mostly work with switch.go. So let's open up switch.go. So inside switch.go, let's go ahead and create a type called switch, which is going to be a struct. So let's say type switch, and it's going to be a struct. So let's declare the first field, which is going to be client, and client is going to be a backend HTTP client, which is a type which doesn't yet exist, but we will create it very soon. So let's say backend HTTP client, and this is going to be an interface because it's very convenient, because any type that implements these specific methods which the interface will have is going to be a backend HTTP client, which is easy to use and very convenient at the same time. So let's declare the next field, which is the backend API URL. So let's say backend API URL. So let's say string, and we need another field which is going to be commands. So let's say commands. So it's going to be a map of string, because string is going to be the command itself, and we're going to have a specific function. We're going to define that every command is going to be a function which returns a function that accepts a string and returns an error. So let's say func, and this func is going to return another func which receives a string and returns an error. Why exactly did I choose this specific structure? You will see in a minute, because this is going to be very convenient. This is going to be very useful later on. So as you can see, we have the struct in place. However, we have a small error. That is because we have a type which doesn't yet exist. So let's go ahead and create this small interface, which is the backend HTTP client. So let's say type backend HTTP client. I'm going to copy this, and this is going to be an interface, and this is supposed to have a couple of methods to represent the HTTP client. However, for now, this is going to be empty. We will fill this out later. Next, let's go ahead and create a constructor function, which is going to be responsible of constructing this switch type, because we don't want to initialize this type by simply creating a struct. We want to have a specific constructor which is going to initialize the struct correctly without us worrying about it. So let's say func new switch, and new switch is going to initialize the switch, and as you guess, it's going to return a switch type back. So let's say return a switch, and let's return an empty switch for now so that this function is compatible, and let's fill this function out. So let's go ahead and create an HTTP client, because as we declared before, this switch type needs an HTTP client. So let's say HTTP client is going to be equal to a new HTTP client. And as you see, new HTTP client is a function which doesn't exist. So let's go ahead and create this function very quickly. And as you guessed, we're going to create this function inside the http.go file. So let's open up http.go. Let's create a type called HTTP client. Let's say type HTTP client. and this is going to be a struct. And this struct is going to have, again, a couple of fields. The first field is going to be client, which is nothing else but a wrapper around the HTTP client, which the Go team or the Go standard library provides. So let's say client is going to be a pointer to http.client. And we have another exported or public field, which is going to be backend URI. So let's say backend URI. And it's going to be a string because we need to know the location of where exactly we will be working with those reminders resources. So let's create another function called new HTTP client. So let's say a func new HTTP client. So let's say URI, and this is going to be a string, and bam. And this is going to return, as you guessed, HTTP client, because as I was saying before, this is a constructor for this specific type. And this one is pretty straightforward. So let's say return, and let's say HTTP client. Let's fill out firstly the backend URI. So let's say backend URI is going to be the URI which we receive as an argument, and client is going to be a pointer to http.client. So let's say ampersand http.client. And this one is going to do it. So we have a new type HTTP client, which is going to be that thing which makes request to our backend API and gives us back a response to the CLI. And now let's go back to our switch.go file, which is the place we call this function we just created. So inside switch.go, as you can see, this is no longer giving us an error. However, we still need to pass an argument, which is the URI or the backend URI. So the backend URI is pretty simple. We're going to get it from the main.go, which we will create later. However, we need to pass this URI as an argument to the new switch function. So let's pass in this argument in the function real quick. Let's say URI, and this is going to be a string, and we're going to pass this URI right here. And there you have it. We have a valid HTTP client, and we could use it later on in this command switch. So now that we have this HTTP client, let's go ahead and create a switch type. Let's say S is going to be equal to a switch, and later on we're going to return S instead of switch. And inside switch, of course, we need a couple of things. We need to fill out those fields. Let's say client is going to be the client we just created, HTTP client. Backend URL or backend API URL is going to be the URI which we will get as a flag, which we will parse from main. So let's say s.commands is going to be equal to a map of string to function, which return a function, which receives a string and returns an error. It's a mouthful of types. However, this is exactly what we will need for each and individual function or each and individual command, you could say. So let's go ahead and fill out a list of commands, the commands which I talked about in the beginning of this video. So let's say create. This is going to be a command, and this is going to map to a function which we will create very soon. So let's say you're going to be mapped to s.create, and let's create another one which is going to be edit, and edit is going to be mapped to s.edit. Then let's say fetch is going to be mapped, as you guessed, s.fetch, and let's say delete is going to be mapped to s.delete. And finally, let's have the health command, which is going to be mapped to s.health. And as you can see, all of these functions don't exist. However, we will create dummy functions for now so that this code is valid and doesn't give us any errors back. Also, as you can see from the code, we have something like s.create, s.edit, s.fetch, which means we are referencing methods on a specific type, on the switch type which we just created, which means they're not going to be usual functions. They're going to be functions which have a receiver, meaning they will be methods. So let's say func, and this function is going to have a receiver. Let's say s type switch, and let's say create. And as I was saying before in the map of functions, this is not going to be a usual function. This is going to be a function which returns another function which accepts a string and returns an error. And you will see in a moment why exactly we chose this structure and how exactly this structure comes in handy. So let's go ahead and say func. This is going to return a function which receives a string and returns back an error. So right away, we will return a function literal, which is basically that function which accepts a string and returns an error. So let's say return func. So let's say this string is going to be command. So this is the command which we will pass from another function, which we will soon create. So for now, to make this function valid, let's just go ahead and return nil as an error, and let's print out something like create reminder. So let's say return nil, and let's print something like print line, and let's say create reminder. So I will simply use copy paste not to waste a lot of time. So let's say, let's copy this create method and let's paste it here. Just change the name to edit. And yeah, again, this is going to be edit. And let's make another copy of this one. Or I should have rather pasted it. Let's say fetch. And let's say fetch reminders, for example. And let's just paste another one. Let's say delete. Let's say reminders. And let's paste another one, which is going to be the last command, which is health. So let's say health. And this is going to be, let's say, calling for health. So as you can see from the code, we have a new switch function which is valid. However, before we get into calling this new switch function, let's go ahead and create another function which is going to be called switch, which basically will parse the command which we give from the command line. So before we create that switch function, let's do a couple of rearrangements just to make sure the things look a little bit cleaner. So I usually prefer to put the type declaration behind or under the constructor so that we have a cleaner structure somehow. It doesn't really matter, you can keep it the way it was. However, I like to keep it this way. Then let's go ahead and create that method called switch. So let's say func, and it's going to have a receiver as switch, and it's going to be called switch. And as you may guessed it, it's also going to return an error because we don't want to avoid or skip errors. We want to return errors back to the top level, which is main.go file. So it's going to return an error. So as we did in the previous video, it's very simple to detect which is the command from the osarg. So you know that osarg of index 1 is basically the command. Osarg index 0 is the temporary location or the location of the executable. So let's go ahead and store that command name inside a variable. So let's say a command name. And it's going to be something like os.args of index 1. And now let's go ahead and use something called OK idiom, which is basically going to look up the map, which we created, the map of commands, and make sure it actually does exist. So let's look up this map by saying command, OK. So basically, we're going to say s.commands, and we're going to provide in the command name. Meaning we're going to try to look up this command name. If we find the command name, OK is going to be true. If we don't find it, it's going to be false. If we do find the command inside this map lookup, the command variable as well will have a value, which is going to be that function which receives a string and returns an error. So now that we have this map lookup, all we have to do is simply check for this OK value. So let's say if not OK, we're simply going to say return, and let's say font error F. So let's go ahead and simply say something like invalid command, and let's provide in the command which the user provided. So let's say command name. In case we found the command or the user provided a command which is part of the map which we declared inside that function when we initialized the switch type, it means we want to execute that command. And as you remember, that command is a function which receives a string and returns an error, so we simply need to call that function twice. So to show you what I mean, let's simply say command, and let's call it another time by passing the command name. So this function simply receives the command and it doesn't care where is it getting from. So basically the constructor is going to assign commands to functions, and the function which is responsible for creating a reminder or editing a reminder doesn't care where this command argument is provided from. So to make the switch function a valid function, we also need to return this at the end. So let's simply say return, and it's also convenient to return this because this function, which is called the second time, returns an error, and this switch function also returns an error. So we simply return that and we don't even care about it because we're going to handle this at the top level inside main.go file. So before we use the switch function inside the code, I think it would be better if we adjusted this print a little bit. So let's remove this colon and let's wrap this in single quotes because the command might have spaces and stuff like that, and it's easier to see that when it's wrapped inside single quotes. So now that we created this command switch type, let's go to make sure we use it inside the main.go file, which is basically the top level file, which will create a binary out of it. open up command and open up client and main.go, which is the file we created in the first video of this video series. So let's declare a couple of variables, which are going to be nothing else but the flags, which we will parse, then provide those values as arguments to the command switch, which we just created. So let's go ahead and say var, and the first one is going to be backend URI flag, and this one is going to be a string. So let's say flag.string, and this one is going to be named backend, and let's provide in a default value. So let's say something like HTTP, and let's say localhost 8080, for example, and let's add in a description as well, backend API URL. Next, let's declare another flag, which is basically the help flag, which pretty much any binary out there has. So let's say help flag, flag.bool, and you guessed it, it's named help, and let's provide in a default value. So a default value is going to be false. Let's say false because we don't want to display a help message by default. We want it to be explicit. And let's give it a useful description, something like display a helpful message. So let's make sure we parse it and provide in those values as arguments to the command switch. Let's say func main, and inside main, we will simply call flag.parse. You guessed it. So let's say flag.parse. Now we have these values. Let's make sure we provide these values inside the switch. So let's say client, and let's call new switch, and new switch requires a backend URI, and we have the backend URI inside backend URI flag. All we have to do is simply call the value of it, because this is a pointer. As you can see, the string method returns a pointer to string, so all we have to do is say backend URI flag by providing a star in front of it. So now that we have the command switch created, all we have to do is call that switch method we just created earlier, right? Right, but before we do so, remember we also have the help flag, which means we want to make sure if the user provided in the help, that means we want to display that helpful message telling the user, hey, you have these specific commands, make sure you use only one of these. All we have to do is simply say if, and again, providing the star, let's say help flag, meaning if help flag was provided specifically or explicitly, or len of os.args equals to 1. Remember, the first argument of os.args is the binary, so if the user did not provide any command, we want to display a help message because maybe he doesn't know all the commands which are available. So let's say something like s.help. Now, after we printed something out, we of course don't want to proceed with the execution of this program, so let's simply say return. So the help command is going to be a very simple command. All we have to do is after the switch method, we'll create another method called help. Let's simply copy that receiver and change this to help, and it's going to return nothing. So let's declare a variable by saying var help, and help is going to be a string, and we want to append the list of the commands plus some custom message which we will be providing. So we're going to say something like for, let's say the name of the command, and let's say range over commands, which we have stored inside the switch. So help message is going to be something like help, and let's say plus equals, and let's provide in the name of the command, and let's also provide in some spacing so that we have a very nicely laid out spacing if one command is longer than the other, and so on and so forth. So we're gonna say something like plus, and let's append another string. Let's say \t minus help, and let's also provide in a \n. So let's say fumpt. So fumpt printf, and let's say usage of, for example, usage of, and let's provide in %s command, and it's also going to have some optional arguments. Let's say args \n %s os args 0, the second argument help, and that's pretty much it on this help message or this help method. So inside the main function, all we have to do is simply call that switch method. So let's simply say s right here. So we have a switch, and now let's say s.switch. This one returns an error. Let's say error is going to be captured inside that variable. If error not nil, it means we have an error. So in case we have an error, let's go ahead and log this out, and then after that we have to test this program to make sure it does work. So let's say os exit let's say 2, and let's say something like fumpt print something like command switch error %s, and let's provide in the error which we received from the switch method. So let's simply say error, and that's pretty much it. So now that we have this main.go file ready to be tested, ready to be run to create a binary out of it, it's actually not ready to be created a binary out of it because we made a mistake in the first video. Well, I should say I made a mistake in the first video, and we did not specify that this is an executable package, which means it's not going to generate a binary out of it when you say go run main.go or go build. And that is because it doesn't belong to the main package, it belongs to the client package and respectively the server package. So let's quickly update the files or the main.go files inside the CMD directory. So first of all, let's say instead of client, let's say main, and let's open up server main.go, and let's also update and say main. So with this change in place, these are now executable packages, which means they will generate a binary out of that. So now that we have executable packages, let's simply generate a binary and test them out. However, I don't simply want to generate binaries, which is why we have created the Makefile in the first video, which means this is the file where we will automate our tasks, including generating binaries. So if you open up the Makefile, which we created in the first video of this video series, as you can see, we have an empty file. So let's simply create a command which will automate all that process of generating the client or the bin client binary for us. So let's simply create a command called client. So let's say client, and client is going to run two commands. One is going to be echo, so let's say @echo building the client binary. So because this is now an executable package, we could simply say go build. So let's say go build, and let's say -o, and this is the output where we want to put it. So we're going to put it in a directory called bin. So let's say bin /client, and let's build a binary from CMD and client, and then main.go. Now this should work totally fine if you're on Mac OS or Linux. However, if you're on Windows, there are ways to install the CMake, which will enable you this command inside your command prompt. So let's open up a terminal window and run make client, which is going to generate this binary, and then let's go ahead and test this out finally. So let's say make client, and if you're getting something like client is up to date, it means we have the directory named client and the command named client, and it somehow conflicts, and there is a quick fix for that. All you have to do is open up Makefile and simply do something like this, .phony and colon, and just specify the name of the command. And if you try to run this again, it will simply work. So as you can see inside the IDE, we have this newly created directory called bin, and inside bin we have this binary called client. So let's simply say bin client, and when you say bin client, as you can see, we have this small beautiful message displayed with all the commands available. If you say bin client --help, as you can see, you'll have the same exact message, which is exactly what we wrote inside the main.go when we did that check for the help flag. Now let's go ahead and test each individual command separately to see that actually those logs or those dummy commands work. So let's say bin client, and let's say create. As you can see, it works. It says create reminder. Let's say edit. It says edit reminder. Fetch. It says fetch reminders. And delete. It says delete reminders. And let's also run health. It says calling for health, and let's also provide in a non-existing command, something like that. It says command switch, invalid command provided. Now everything is good, however, I don't like the fact that we don't have a new line at the end of this log when we provide an invalid command, so let's quickly fix that. So inside the switch.go, let's simply look up for the switch method which we created, and instead of simply saying invalid command, let's also provide in a \n. So because this video is getting super long and nobody likes long videos, YouTube doesn't like long videos, Final Cut doesn't like long videos, you don't like long videos, I will have to wrap this up because it's getting too long and it's getting out of hand, and we should wrap this up and see each other in the next part, and chances are I will upload both of these videos at the same time, so you will not miss anything.